As just covered, variables are data containers, and we use them to hold information, maybe change it, access it, work with it, do whatever we want with it. And data comes in different types. Those of us who are used to Java are used to something called a statically typed variable. The type of variable where, well, in Java, I would need to define the type of a variable, then give it a name, and then assign a value to it. The typing in the very first place when I create the variable locks in the type of variable that it is when it's created. This is different in Python. We don't actually tell Python itself what type of variable that we want. We allow Python to determine that based off of the contents of the variable. So if I was to do something similar to above to create the number 3 in Python, I would simply say num equals 3. Python knows that 3 is an integer, and therefore the type of data stored in num right now is an int. Let's see proof of this. I'm going to have Python print out the type of data inside of my number. So I'm going to print the type of my num and have that report to my console. And you'll see that it says down here, it is an integer type object. What if I said word equals, and now I'll type in hello. Now for a string, we need to make sure that we actually have these apostrophes around it so that it is considered the correct data type. You could also do the double quotation mark to represent a string as well. You have two options. How do I know this is a string? I'm going to print out the value of the type of this variable. This one is a string. We also have another type of number. I'm going to call this num2. I'm going to say 3.14. I'm going to give it this decimal information. And let's print out the type of num2. Right in the middle there, we have integer, float, and string. Finally, one more type of data, on or off equals true. Well, what type of data is this here? This is, if I run this, a Boolean or a bool. Notice the true is capitalized. The false would also have to be capitalized in here. If I try to write a lowercase true or a lowercase false, it gets a bit confused. So these kind of commands are capitalized ones. So these are our four main types of data. We have our ints, which are whole positive or negative numbers. We have our floats, decimal values. We have our strings for text. And we have our booleans for true or falses. And these are the four core main data types of Python. And once again, we don't have to state in advance what type each of these things are. It will be dynamically typed by the Python interpreter once it recognizes the type of content in it. Now this leads to some interesting scenarios where I actually can work with different types of data in the same variable. For example, what if I set the value of num2 to just be resetting the value of num instead? So I'm using the same variable name. And instead of 3.14, I just said 3.0. The same number technically, but the 0.0 meaning that it's now considered a float. If I run this, you'll see that it's still listed as an int and a float, despite it being the same variable reference. In Java, as you might have studied before, you would not be allowed to assign 3.0 to num, because num would be considered an integer, and we can't mix and match data types. But because Python is dynamically typed, I'm reassigning a new type of data to this variable, and Python has no problem with that. Num is now a float. I could technically do the same thing here if I wanted to, and replace this word with the num variable, which again has been defined up top twice now, but now I'm replacing it with this hello term, and it's still considered a string. And I could do the same thing with this. Instead of on or off, I could name this num as well. And this now is typed as a bool, despite having the same variable name. So this allows for a great amount of flexibility in Python, but it also comes with its own inherent risks, because we don't pre-type or statically type our variables. That means I could define a num in one spot and then carelessly replace it with a different value later on, a different data type, and if I'm processing the logic of that variable, let's say I'm expecting there to be a number, but then I replace it with a string, it'll totally allow me to, and then I try to do some math on a string, my program might crash and burn. So the flexibility of this dynamic typing is really convenient, but it also can become really troublesome for troubleshooting and figuring out where your bugs are popping up if we're not really careful in how we write our software. The last thing I want to show you in this tutorial is that we can actually turn one type of data into another. Let's scroll down and add a bit of white space down here. So I'm going to create my variable. I'm just going to call it var, and I'm going to set its value to 3. But what if I wanted, you know what, let's actually just delete all this stuff up here so it's nice and clean, and I'm going to print the type of my variable, and I should expect this to say the value is an integer. Perfect. But what if I wanted to set my var variable to be a different data type just without changing its content at all? What if I set my var to be the float version of my var variable, and then I check the type of var? Now var is considered a float. I didn't reassign any new value. What I did was used a process called casting, where I take one data type and I tell it to behave as another one. Think of this as being extracted from the idea of casting for a film or a TV show. You have an actor who might, or an actress who might perform in one role at one part of the day, and then that evening they go to the other set and they perform a different role. They can be cast into different roles despite being the same person. And in the same way, my variable initially was identified as being an integer, but I can kind of force it or cast it into the role of a float by just telling Python, hey, I want this to become a float. I can do something similar with a string. I can cast my, it's just str. I can cast my variable into a string, print this variable out again, and it has the same value. Let's just print out what it's going to look like. What if we print out this var at this point in time? What's going to pop out? 3.0, but this value is actually a string type data by the end of the logic, going down from top to bottom. It began as an integer, and then I cast it into a float and printed out that type, and then I cast it again into a string. Interestingly enough, I can actually do this. I'm going to have a word, and I'm going to make the word the number 100. Because it's a number, Python is smart enough that I can do this. Word equals the int version of this word. And then I'm going to print out the type and the value of word instead of var here. And when I do this down at the bottom, we'll see that I have an integer object with the number being 100. So I started with a string, and I cast it into an integer. Now keep in mind, this only works if you actually have a real number in the string that Python can figure out how to turn it into an integer. But it's really easy to go from string information of numbers into integers, or I could have done this to a float if I wanted to as well, through casting. It goes both ways really seamlessly. But once again, because it's so easy to cast back and forth, you have to be careful about when you cast things that you don't then process it assuming that it's the original data type. With great flexibility comes great responsibility. Hopefully that gives you some new ideas to consider with this new flexible world of Python variables.